Okay, so what we're doing today, it's 1.1.4. I want to overview it quickly. Last class struggled to grasp what they're supposed to do. I'll give you a hint. A big part of that was they didn't actually read the instructions that I'll give you. So please read the instructions. I'm going to give you simplified instructions to make it even easier. And then you just go to the My Project Lead the Way, and it's all right there. If you don't understand what you're supposed to do in that step or you're confused how to do it, let me know. But I spent half my day yesterday telling kids, like reading the prompt to the students. That was their question to me. So I don't want to waste my time or your time doing that. But I want to give you the overview. Today's activity was supposed to be we take the launcher we made, or we make a new one, and you actually launch it to like kind of a bullseye or a dartboard that's on the ground, and you actually document where each launch lands, and you mark it on like a grid paper, on like an XY coordinate, kind of like this. So we would have gotten a sheet of paper. Here's 0, 0. That's like bullseye. And then you launch it on the ground, and you mark where every beanbag, your 10 trials or whatever, you mark where they'll land. So that's your data. Then what we're doing today, we're going to use the distance learning. So virtual students, this will be the same as you would have done, but everyone's doing it because they provide data so that we don't have to take the time to, because I don't have any more supplies, and it's just a better use of our time to just focus on this. That's what we're doing. You would launch that beanbag a bunch and get your trial. This is your data. Now we need to do some data analysis. We're focusing a lot on precision and accuracy today. Those are two very important words that are similar but very different. Again, there's an explanation as part of this activity that explains those so you understand what those mean. And then we're going to actually do some data analysis. We're going to use Google Sheets, spreadsheet software, to do some math for us. But the point is, you would launch all these and you measure with a ruler. Okay, how far off from the origin am I? Say that's 2 millimeters, whatever it is. And I measure each one of these and record that. You're going to get that data. It's going to give you, like this, it'll tell you the coordinates of this is 5, 2, right, on an XY coordinate system. To get here, I go over 5, up 2. It'll give you the coordinates, and then it'll also give you the measured distance. If I put a ruler down there, I said, that's about 10 millimeters. That's the data you'll get, and then we're going to do data analysis to that. We're going to actually calculate this distance rather than the measured. And then we're also going to look at all of my data points. If I put a circle and I make it as small as I can to include all my data points, this is going to tell me something about my data, and I can use that to approximate how close my measurements were. And again, that's kind of the gist of what this is, except we're going to skip the building and testing and go straight to the data and then the data analysis, because that's the focus of this activity. Does that make sense as an overview, what these numbers will mean, so you understand, okay, what am I reading? Well, the coordinates of like where the beanbag landed and the measured distance from the goal right at 0, 0. And it's got instructions on how to calculate the actual distance. You'll use Google Sheets to do that for you. It's a really cool, something you probably haven't seen before, but I'll show you that. Another thing, let's see. So you guys, I'll have you get your math books out, and again, My Project Lead the Way, get logged in. And it's 1.1.4. You guys can navigate there while I get the projector out. So again, when you're in here, 1.1.4 means it's unit 1. There's 4 units for this class. We're still in the first quarter, or first unit. So I go to unit 1, it's 1.1, so that means it's lesson 1. That's like a big week or 2 week chunk of the unit. And then it's 1.1.4, which is the specific thing we're doing today. Just a reminder that that's how it's always going to be structured. So if I tell you 2.1.1, that's Unit 2, Lesson 1, Activity 1. And it's all here. It's, a really clear hierarchy of how to get there. And it's going to be called Targeting Success Using Data. So I don't want to spend a lot of time, like I did last class, going through the instructions, because it's all there. The one thing that I'm going to leave this up here. I'll have to show it like this. I'm making new instructions because there are specific things that I want you to skip. So instead of going 1 through 19 or whatever, I'm telling you just read 1 through 5. So you read 1 through 5. On step 6, do the check for understanding. Do that. Then I'm specifically saying, look for this and open that, and you'll get a Google Sheet that's your data. Pick a team. It doesn't matter. It's just given data. Then, after you do that, go to step 8 and actually calculate things. So step 8 will tell you how to do that. So read step 8. You're going to use that same data to do number 9 and record this. So all of you guys in person, I'm going to have you write this down on a sheet of paper. So I think there's 9A and 9B. I can't remember. But whatever you're recording for 9, put on a sheet of paper because I'm going to have you turn that in. If you're a virtual student, I'm going to have you record that. Just make a Google Doc and submit that. Otherwise, you could write it down and just take a picture and submit the picture scan of whatever you're writing down. All right? But you guys, I'm going to have you do it on a piece of paper and turn it in before you leave. Then do 10 through 12, again using the same data. You only need to record answers 10 and 12. All right? So you need 10 and 12. Skip this, do 14 and record it. Skip pretty much the rest of the activity, and then just do conclusion questions 1 and 2, and that's it. All right? So, let's see. So a reminder, you're going to have, it'll be question 9 I have you record. It's 9A and B. Number 10, there's A and B. 12, there's just one thing. And then step 14 is just one thing. And then 2 conclusion questions. All right? So again, I'm leaving this up here all day so you can follow along with it. Right? I want you to do this, but it's all referencing the Project Lead the Way activity. All right? And again, everything's there. Make sure to read it because there's a lot of stuff that tells you how to do it. Right? If you still don't understand, or you're like, I read it and I don't really understand how I'm supposed to do that, then let me know. But I don't want to read the instructions to you so you can figure it out. I want you to be able to do that yourself. All right? The other thing, when you guys get to step 8, so I'm going to give you guys some time to do this opening, and I might show you step 8, because a lot of you guys, it's brand new. I think I want to do that just because a lot of you guys haven't used Excel formulas often, so I'll show you the trick for that. But right now I'm going to give you guys time to start, work through basically steps 1 through 6, and then when you get your data, I'll try and do it when everyone's at the same place and show you all at once. Alright? Any questions? Alright. What's up? You gotta be kidding me. Put it in your phone. Yeah, you need, I was gonna say, you need to write it down, put it in notes. Huh? It's right this. So after step 6, you're going to be looking for this link, and it'll open that in a new tab, and all your data is right there. So all right, there you are. Make sure to write it down, throw it in your phone. Especially if you go home on a weekend and you need to do an assignment.
Just when you put your username and password in, click remember.
It didn't. I don't know if it deleted your cookies or... Yeah. So, Mikey, you got that? Okay, and then your password, same as it's always been. Alright. Come on. Alright, so I'll go back to that and leave that up. Okay. No. Again, this was supposed to be a group thing, but I'm giving you the data, and so you do it individually. You can help each other, but it's supposed to be on your own, doing the data analysis. What's that?
No, I just didn't know if you were, because you said feedback.
Yeah, that was that group activity. This one, if we had the time and, again, the materials, we would do the same thing. We would build a better one, and your group would actually get data in person and use that. Yes, so I'm telling you, read 1 through 5 so you know what this is, like what the process is, but you're not doing it. Here, you're just going to get the data and go from there. Yep, perfect. Drew. You don't. It just says download a Google Sheet from one of the team's listings. So you can do eeny, meeny, miny, moe if you wanted to. And again, a reminder, you guys, I'm going to have you guys turn in that sheet of paper with all the things I'm asking you to report down. I'm going to have you turn that in before you leave. Yes. But I could do it in 20 seconds. But you can't. Right? So the first thing is doing it for one of them. If you can do it for one of them, that's the hard part. The rest, you let Google Sheets do it for you. Yeah. Once you do it once, it literally takes 1 second to do every other data point. No. You make Excel do it. Okay, so crank that up. So this is the formula. The first part is to understand how the formula works, right? So basically you just say, what's the change in the x position? I'm going from here to here. Well, how far in this direction does it change? How far in the y direction does it change? You guys, the distance formula that it's using, just so you guys understand where it's coming from, you guys have gotten down to distance formula, this guy. It's not bad. All this is It's Pythagorean theorem.
Oh, never mind.
Yeah.
Never mind.
You guys done geometry?
Yeah.
So if you have a grid and you have this your start point and here's where the beanbag landed, I want to know this. Well, it's a coordinate system. This is given by some x and some y.
So if it's
What-
coordinate, wouldn't it be like slope?
Yes. No.
How far would the zero?
That's not
The
Pythagorean.
slope only does the angle, like how tilted it is. We want the actual length of this. So all I do is basically A, B, C, right? A squared plus B squared equals C squared. Well, I want the length of C. I want the length from the origin to my actual data point. That's where it landed. Well, I'll just do the square root. Square root of a squared is nothing. So that's my distance. That's where it's coming from. Well, what's the length of A? It's this x position minus 0. x2 minus x1. B is y2 minus y1. That's all it's doing. So when it says distance formula, it comes from Pythagorean theorem. Just so you guys know the math that's going on. In every situation, we're measuring from the origin. It's 0, 0. So you just put in 0, 0. Also, hint, hint, this little link right here will be really helpful for you guys. Hint, hint. That's all right. I just wanted to, a couple of you guys were there, so I wanted to throw that out there. Let me keep this up so you guys. Well, so it says the formula equals blah, blah, blah is how you type that mathematical equation into Excel. So it told you exactly what it is. Yep. Yep. If you copy paste that, this is like the formula in Excel that tells you, hey, do this math. You miss the equal sign, but then you paste. And then hit enter. So one thing I'm going to show you to confirm, if you come up in here, this is like the formula bar, and then it outputs like the result. In here, Google Sheets is smart where, one, you do 0, 0, because every point is going to be measured from the origin. So they put 0, 0 in for sure. This is X, and it's highlighted, right? And then this is the corresponding Y. They're in line, so I know it's the same data point. So that's good. So now I know my formula is set up correctly. So it did the math for me. Boom. Now, this is the trick I was going to show you guys. This little square down here, you can make Google Sheets. That is the beauty of Google, like Microsoft Excel or Google Sheets. What that does, and you can check it. If I look here, look, it took the right X and the right Y and calculated it. It knows, basically, it's like saying, take this cell to the left and this one to the left, and calculate it. Well, if you move that down, it's like, wait, I want to go to the left and to the left. It knows that. It does it automatically.
Yeah, I have the Google Sheet.
And what this is doing now, this, you're a pickaxe. Label this, just so you know, that's calculated distance. You measured it, like with a ruler, and now you calculated it mathematically. You can see there are some differences. And that's part of what you'll do, like in terms of interpreting this, but it's also just good to know what you just did. One part, they measured it on the paper, reported that. This one, you're mathematically calculating it and seeing how do they match up or how do they not match up.
Okay, so I got this. Now we're
Okay, is everyone pretty much at the data? Do calculate though that so you got the data. Step 8 was using that distance formula. So if you go back to activity, step 8 is where it
I gotta calculate the problem.
measured. So they physically took a ruler and measured it. Yeah. So you guys, you will really want to pay attention because I'm going to make your life really easy right now. So when you get to, after you do that check for understanding about precision accuracy, if you go and get your data, you just pick one of the teams. So I look for this guy. What team do you want me to pick? Two. So I'm going to make a copy of Team 2's data, and I'm going to use their data to do my analysis. It doesn't matter. So then I'm going to go back to my instructions. Right? I picked my data. You don't need number 7 really. Now it's telling me use the distance formula to calculate the distance of each landing location to the target center. The target center was 0, 0. That's my bullseye. Well, I want to know how far each point was from the bullseye. I want to calculate that. You'll notice they already did that. Well, yeah, they measured it. So in person, they took a ruler and said, yeah, it looks like about 5.8 centimeters. I want to calculate distance. Calculated distance. What is that? Where did you get that? Is that your data? No. You pull the data from your spreadsheet, your activity. No, you don't need to. Remember I said you're doing control up? Right there. Click that link. Don't use that link.
Yeah, Drew.
All right, so I'm calculating distance. I need to use the distance formula. Well, how on earth do I get Google Sheets to do the distance formula for what I want? It gives you the hint. This is the actual formula in Excel or Google Sheets. This is how it does square root. Instead of on your calculator, you push the square root button. This is how you do it. And it has it already made for you. So I copy that whole thing. I need the equal sign. Google Sheets needs an equal sign to know, hey, what I'm typing after this is actually a formula, not just a bunch of letters that I'm putting in the box. I want it to actually do the math. So I want to do it for this first data point. So I'm going to put it over here. Boom. Again, make sure you have the equal sign. And you need to have it be in line with the first data point. If you go up here, it highlights, okay, I'm taking the x-coordinate, the orange, and subtracting it from the 0 of the target, right? Huh? Yep, it does the math for you.
I just do that here in the coordinate framework.
Yep, so you plug in the distance formula, and you have to use that square root function that it gives you. It tells you the answer. Well, you put it in the distant calculated column for the first data point. And it knows take A1 or A2 and B2. Huh? They shouldn't. What you do next, this is the magic of Excel or Google Sheets, you guys. I just had this formula take this box and this box and put it in and do this math. And it spat out the answer for me. If I see this little square, if I click that and I drag it, I want to tell Sheets, do this a bunch more. I'm zoomed in too much. Right? I take my little square and I drag it all the way down to the end of my data points. Yes. This is, again, the magic of Microsoft Excel or Google Sheets. What it does is this formula says, okay, take this box to the left and this box to the left and do this math. If I tell it to repeat that, if I copy that formula, Excel knows, okay, I'm on a new line. I need to take those two boxes I was calculating and I need to move them to match. So here, takes the far left, second far left, does the math. So it's doing it all for you. 5 seconds. Got it? That'll make your life a lot easier. Now you have all of your calculated distances. So you have step 8 done. And then number 9 is just what you would start writing down. Answer these questions. Are there differences? Yes or no? What could cause them? Make sense? So that's kind of my little pro tip, because you guys haven't probably used Excel or Google Sheet before. That's like the pro tip for doing that easily. What's the instructions say, Drew? You read 1 through 5. Did you do 6 to check for understanding? Next it says click and open DL launch data activity 1.1.4. So you have just finished 6. Yep, so you got your data. You exported it to data. If you go to step 8, what's step 8 say? Yep, you need to use this formula. Well, if you were watching me, you would have already had this done. I showed you that hint is going to be really, really helpful for you. If you click on that hint, it actually gives you the answer. It tells you the answer. Then, do the first one. Take that little square and drag it down, and it'll repeat that math for every single data point. Oh yeah, measure the distance from the origin, bullseye, center of the circle you just made. So you want the distance. You want the distance from the origin to this point, -5, -2.5. Yeah, well, you can make Excel do it for you, right? This is taking an X and a Y coordinate and measuring the distance from the origin. I already did that. Well, I'll just put in 2 new data points and have it do the math again. So if you go to the bottom, I would skip a space and put in your estimated center of that circle, and then have it do the distance formula for you to see how far is that point away from the origin. You do, but I had you skip a step because you'll need that space later. So click enter or go over here. Well, take this, take that little square and pull it down. There you go. You're telling it, repeat this calculation, but on this row with these 2 data points. Those 2 data points are your estimated center. How far is that estimated center from the origin? That's what it gives you. Do it like 2 or 3. Also, did you write down step 9? Yeah, the entity. Yeah. So that again. You guys, I'm drawing your guys' attention, making it even easier. These are the things you need to record on your sheet of paper and actually submit. I'm making it even easier. You guys remember, what do I need to put? How do I get full points? Okay, I want to make sure I can keep this. If you go back to your activity in my project leader way, it's saying look at this link, click on this, click that link, it'll open the data for you, it lets you download this specific. So it'll already be in there, that one, you don't gotta put it in manually. Yeah, that would take forever.
I'm gonna let you know if I have a combo
They'll make a copy for like that, and then you just kind of pop it in there. I'll say a lot of
That's what
times.
happened.
And then just make a new column, and that's where you put in that distance
That's
formula.
what happened. We didn't have enough energy at the beginning. So we gotta make sure we
Put that in.
definitely the best school in the face.
Huh? On the Facebook, they even recorded all that. Nope. Again, Drew, back to the instructions. Use the given data to complete 9, record on a sheet of paper or a Google Doc. And I told you guys, in-person students, do it on a sheet of paper so you can turn it in. Virtual kids are going to do a Google Doc. And again, I highlighted, to help you even more, these are the things you're going to have to record.
They got a couple good players. Yeah. Okay, so their quarterback's pretty fast. They'll definitely run the option. I double back and say. And the receivers are.
Oh yeah, estimate the center
That
that's
knows
so
where
you go up, whatever.
But he don't line straight up, so that's
Hey,
bad.
originally you gotta look at theirs.
So making I think he wants
So this is their data. You need to approximate the center of that circle. So what I do is put your mouse like about where you think the center of that circle is, and then just look at, okay, what coordinates am I hovering over? You might need to zoom in.
Who are they
That's
playing?
easier. It's a pretty small grid.
So it's kind of good though.
Bro. Their guard just missed this Oscar great. They don't get great.
So yeah, that's my advice. Put your mouse where you think it is, and then just read, okay, what
Their
coordinates
center missed that. That's crazy.
Yep, there you go. Perfect. So you would record, that's my approximate center of my data. That's my estimation.
79's the only big one.
And then 10B, I'm pretty sure asks,
Yeah.
calculate
It's really slow.
the
Yeah, that's gonna be
distance
pretty easy for
that the
you,
center
Ben,
of
or
your
you,
data is from
me,
the
or
origin.
you. It's gonna be really easy.
Well, how would you calculate the distance?
I should be able to pass watch him.
You literally just put in a
If
new
you-
coordinate,
If we're not pass
kind of
blocking,
a couple
usually
spaces below your data, and just pull that
Unless it's a
distance
pin
formula
yeah,
down
you're by
and
yourself.
and that's going to be your like measured center of the circle. You approximated the origin, and that's what that answer is telling you. Like the center of my data is approximately blank centimeters away at the center of the data. So I know. Yeah, go ahead. Sign up on the sheet. Sorry to make you wait for a couple minutes. You could have followed that man. I thought you had another question after this.
Damn, he just bullied.
Jesse, what's up? Okay, so go back. So go back up. It actually shows you your team's data. Right here. Did you do team one? Okay, so it gives it to you. I would just do
That knows where it starts.
Yeah, so if I have 29 units on this side of the axis and say 19, you just add those up. Yeah, whatever. Yep. Yeah, because it gives you the data, so I would just read it off the graph about how wide it is. You counted how many units. So, centimeters. Again, you guys, I want to remind you. Check for units. Specifically, what you're writing down. If you just give me a number, I'm going to take half point off because you didn't tell me the units. Are you telling me it's 8 tons? Is it 8 megapixels? What are you talking about? Units are really, really important in all sciences and engineering in particular. So that'll be a big part of this class that I want you guys to get into a habit of. Justin, did you have a question? No? Okay. Yeah, put it in that. Yeah. So if you go up to that cell, click in this all in the bar. If you click in there, it'll actually highlight. So you can confirm this cell and putting it in here to kind of get in this cell too. You can confirm like, okay, it's doing what I'm telling it. Then you hit enter. Plot. Yeah, right. Now you want to do the same thing for all your data. Okay. Well, instead of case, you click, highlight the cell that you just calculated. Take that little square and drag that all the way to the last data point. Cool. And then let it go. But what you just told it to do is take this formula and do the same process for every single row. So it knows, okay, I moved down a row, calculate it, I'm not using these data points, I need to move those. If I move it down again, I need to move my data points. So it does it automatically. So now you've calculated the actual distance that each point landed on, and you can compare it to somewhat how measured it per ton. You can actually see the measurement here. So not now, hold on. Because this kid did something stupid on his computer. Where's the other? Where's all the other reports? No. Record on a sheet of paper or Google Doc. Drew, you're not reading instructions, okay? You're not slow, you're just not taking the time to read.
He's not so mental.
Use the given data and complete step 9. Step 9, if you look in your activity, this is step 9. So you complete this step and report it. You can do both, but I'm telling you, you need to put it on a sheet of paper or Google Doc. This is yours. You can do whatever you want here. I was telling you, I need you to record it so that you can get them. I can't access this. You certainly could. But I'm telling you, for this assignment, I can't see it. So I need you guys to put it on a sheet of paper or Google Doc. You're good. Yes. No. I'm not going to answer that one. If you still can't figure out a bit, I would ask Drew, because I just tell Drew how to do that. Otherwise, no. You can't drink that or I can't see this. Right? No food or drink in any classroom except for a water bottle. If you want to try and sneak it in there, that's fine. You can ask Mr. Q if that's acceptable. I don't think that's acceptable. Again, I was told that the school's policy across the board, no food in any classrooms and no drink in any classrooms except a bottle of water. So that's what I'm going to enforce because that was the school's policy. So that I don't think applies, so I would be careful.
Would flavored water count?
So
I didn't hear you.
this is all you're submitting. So that's why I wanted you to record those key things on a piece of paper so that I can take it and I grade it. Yeah. On here, on the My Project Leads the Way, that page, you see there were spaces to fill it in. That's for you. So I always recommend students to put it in there. I can't access it. I can't go in and see like, hey, what did Jesse put for 9A? Because that's your site, which is why I'm having you kind of copy those over so that I can get that and give you points and stuff. And that's also why I said put that on a sheet of paper. The virtual kids on the say, hey, put it on a Google Doc and submit it. None. Give me 5 seconds. Hey Lou, I think I saw you were doing a Google Doc, so I need you guys to do a sheet of paper. I need a hard copy submission. The Google Doc is for the virtual students because they can't turn in a hard copy for me. Yeah. So just get a sheet of paper from somewhere and just copy that. Okay. Unfortunately, I don't. I have some toilet paper though. It's the only thing they gave me, which is weird. So I apologize. I need to adapt that. I need some. If I got paper towels, but those are like real dumb. Not ideal. This one literally just estimates what data you take. You do team 4, team 2. If you scroll up, look at their data, right? Click on it shows you. This is their data points and the they drew the small circle. So you just need to estimate where's the center of that circle. So you could, if you zoom in, it will help. But otherwise, I would just say put your cursor where you think the center is, and then read off the mirror that falls on the coordinate system. And that's your estimated center of the circle. Are you sure it's 5-4? Isn't it on the negative side? Right? Negative like 11? Or do we not do? Right? So that's negative 5. That's negative 10. The x direction is about negative 1. And then you go up. But again, it's a coordinate system. You have to write x first, then y. Scroll down, you see how it has. That's a coordinate. The x coordinate and the y coordinate. So then that's one thing I'm going to have to record. That's report 10. So give me 10A, say it was all of negative 5. You estimate where that's center. It's not exact. And then B is saying, okay, wherever you estimated that center to be, calculate how far that is from the coordinate. Well, you already calculated the distance of a coordinate from the origin. That's in your data sheet. So what I would do is just go in here, skip a couple lines, and add a new data point. AKA your center that you just found. Yep. And then take the distance formula, you take the last one, do that square trick, and pull it. Not that one. Have it do the math for you. There you go. That's 10 feet. You calculated how far your estimated center was from the origin. Yep. Oh, that's the same. So, one, you get step 9 before you see it. Just make sure you both what I'm going to do. The entries are 19, answer conclusion questions. But back to your question here, you estimated where the center was, and you found the coordinates, right? Yeah. So now you need to say, okay, how far away is that point from my estimated center from the board? How would I calculate that? Yeah, you've already done it. I would just make Excel do it for you. It takes any XY coordinate and calculate the distance from the origin. Well, you have to do the XY coordinate, just add it on. So go to the first couple lines. And then put in that estimated center of your circle. And then take that last calculation and do that little square trick and pull that formula down to your new data.
You just answer a question.
Oh, drag it down.
Each team member should spot.
Does that make sense? So again, that I think is something. That's number 10. Another thing you need to do. Number 9 is different. You got to read that. Basic system. Calculated what could cause this difference. And then 10 was what you just did. So you need to report 10A. Tell me what was your estimated center of your circle, and then what did you just calculate for 10B? Does that make sense? No, you don't have to. That's more like you would do this here for like your own. So tech, did you do the averages? Okay, so technically I don't need this, but you need this. I'm only looking for 12. After you found this, you do 12. So go to your data. So you use the average formula. Oh. If you read this, calculating the mean of the x coordinates using the average function in the spreadsheet. So if you come down here, because I told you to skip a step because it's right here. I take the average function. I want here. Here. And then you can even make these. Okay, I just took the average of all my data points above me. You tell Excel to do the same thing, but just over here. Do that drag. Yeah, that's good. So one, it's good to know how to actually do it rather than just telling your computer to do it for you. But this is, again, there's so many things you can do in a spreadsheet. So Nolan, first you want to start with, in here, you start with the equal sign. In the spreadsheet, equal sign means, hey, I'm telling you a formula, not just a number. In the notes on your activity, it says use the average function. So this one, and click it. It says it's like launches the average function. Now you just need to select what data. So you scroll up and click the first data point. And then if you scroll down to your last data point, yeah, you can do that too. Make sure you yep. And then hit enter. What it does is it takes the average of everything you selected. Then, instead of doing that again over here, tell Excel for Google Sheets, pull it over, basically say do the same thing but with everything above you. And then you already had your distance formula pulled out to take these coordinates. This represents your average x and your average y coordinate. That's like the mathematical center of your circle. And then here, that's the calculated distance from the origin to your mathematical center. Which is all 12, right? Yeah. So that's how you do that. So
When is this due?
End of class. The key, it might seem tedious, but it's all the instructions are all there. Like that step was all over here. And then again, number 12 was what you just did. Once you find your averages, W, X, W, Y, do the distance formula on that. Huh? Yeah, because Nolan, he had already dragged the formula down. Well, these are zeros because there's nothing here. So as soon as you put in the data point in, Google Sheets is like, oh, there's new data. I'm going to run my calculation and it does it automatically. So there's a lot of things you can do, like a spreadsheet. For 10B, right? Yeah, 10B is the data. That is the answer. Did you get 7.28 for your estimated center? Yeah, so that is just estimated center. So that's right. Then you go down a little more, step 12. So this, make sure you do step 11. Right? But step 12 is, now instead of estimating the center, you're going to actually calculate the center and do the same process as calculating the distance.
Oh, you guys
This
are
is important to mathematically calculate the center. You eyeballed it, now do it mathematically, and then repeat that. That's what 12 is. And again, Nolan and Andrew did that. They can show you how to do that. But it's easier than you think. Not yet. I'm going to collect them all at once. You got units? Make sure you get units. Brody, you got units on here? I took a lot of points from the other classes. They didn't do any units. So just for mine. Cool. Yeah, that's what a unit is.
Well, yeah.
Meters, centimeters. Yeah. Malachi. That's right. So we'll do a hard shutdown, and then I'll just give it a couple seconds, and then try to blow it up, and let me know if it doesn't come back up normal. It should. It should like restart. Hey guys, just to help you, make it even easier on you, when you guys are doing like here, open whatever team of data you picked, that shows you the data in the smallest circle. For 10A, you just need to eyeball it. This one even shows it to you. So I look, okay, that's about -5, +3. So I record that. Then I take this data point. I'm going to just put it in Excel as a new coordinate point and do my distance formula. Make it calculate the distance from that estimated center to the origin. 11, make sure you read this step. You need to do 11 in order to record step 12. What it's telling you is that if you do equal average, there's actually a formula, and you pick all your x points and calculate it. It'll do the math for you. Then you can do the little box trick and pull that formula over and have it do it for all the y's automatically. Then I'll just have the distance formula do it. I have the calculated center of my circle, and I'm going to do my distance formula for that. There's my answer. The distance between the origin and the calculated center of my circle. That's what 12 is. I just did it. Right? Don't need 13. I need to go to 14. Well, I need to estimate the diameter of my circle. Well, I go back up here and I estimate. It looks like it's like 19 over here, and then from 0 over to -29. If I add those two up, that's the diameter of my circle. There's step 14, done. Then I skip 15 through 19, and I do the 1 and 2 conclusion questions. I'm not doing the going beyond, and I'm not doing number 3. Right? And then you're done. So you guys would submit a piece of paper with all your answers that I said. Distance or virtual students, you're going to do a Google Doc with all the answers that you had. And that's what you're submitting for this activity. All right? So I'm going to go ahead and end this recording since it's just work time the rest of the day.
Do the